distance vector routing protocol, guys? Some properties of distance vector routing protocol. Okay, OSPF is which type of routing protocol? Dynamic routing protocol, distance vector, advanced distance vector, or link state? Which type of routing protocol? Link state. So what is the difference between distance vector and link state? Number of hops and direction. You can say distance vector calculates metric on the basis of distance, on the basis of hop count. But link state routing protocol uses link bandwidth to calculate metric. Hello, is my voice breaking, guys, for all? Yes, Jyoti, am I audible to you? Okay, my voice was breaking. Voice is low? It's okay. Tomorrow will increase some internet speed as well. Yeah. So you can say distance vector routing protocol calculates metric on the basis of distance, that is hop count. But link state routing protocol uses link properties to calculate metric like bandwidth, delay, load, MTU. These are what? Properties of link. So link state routing protocol uses link properties to calculate metric. According to distance vector routing protocol, always shortest path will be the best path, right? But according to link state routing protocol, best path means it will check best path on the basis of available bandwidth, on the basis of load on the link, reliability, which path is more reliable. This is one difference between distance vector and link state. Any other difference? Tell me, guys, other difference. Link state, sorry, distance vector routing protocol always sends full update, correct? Full update means complete routing table, which will increase the bandwidth utilization of link. Distance vector routing protocol always sends full update. Then second difference, third difference, guys. Distance vector routing protocol always sends periodic update. Am I right? Are you guys clear with these points or not? What is the meaning of periodic update? What is the meaning of full update? Hope you guys are clear with this all. Yeah. It can be it can be any message of routing protocol, but right now I am talking about the update message, which is the main message of in the routing protocol, right? Main message is the update message, which router used to share network information. Why we are running routing protocol, guys? To share routing information, to share the routing table. So main update message is periodic in case of distance vector routing protocol. Got it? Update message, bro. Update message. I'm talking about update message. Done. Then any other difference? Hey, I'm expecting at least 1 to 2 difference from your side. Okay, let me, yeah. Yeah, that is link properties. I already told you. OSPF uses link properties to link state routing protocol uses link properties to calculate best path. OSPF note. I'm not asking you the difference between EIGRP and OSPF, bro. Difference between distance vector routing protocol and link state routing protocol. See, there are two types of routing: static routing, dynamic routing. Static routing, in static routing, administrator manually configure route on the router. In dynamic routing, we will run a process on router. According to that process, routers are going to share the routing table, right? Again, we have two types of dynamic routing: IGP and EGP. Interior gateway routing protocol and exterior gateway routing protocol. In IGP, we have multiple types of, again, routing protocol like distance vector, advanced distance vector, and link state. So I am asking the difference between distance vector and link state vector routing protocol. That's it. OSPF. We'll cover everything about the OSPF routing protocol, guys, from CCNA to CCIE, you can say. Whatever things we have in OSPF, we are going to cover in maybe next 10 class or 6 to 7 class. It will minimum take 6 to 7 classes, right? So in the CCNA, if you will check syllabus of OSPF, so there is introduction of OSPF, then OSPF fundamentals like types of router, types of areas, link state advertisement, types of LSAs, OSPF messages type like packet types, how many types of messages are there in OSPF, how many messages are there in EIGRP, how many messages are there in EIGRP, guys? Yeah, 5. May I know the name of each? Hello, update, then query, very good, query, reply, and acknowledge. And how many messages are reliable message in EIGRP? Update, query, and reply. Update, query, and reply. What is the use of hello message? Correct. To track the neighbor and to discover the, yeah, exactly. So to discover the neighbor and to check neighbor is alive or not. What is the use of update message? Yes, network information. What is the use of query message? Whenever a link bill goes down and if feasible successor is not available in the topology table, then router is going to generate query message. Use of query message, it is used to inform neighbor that I lost the path. So if you have alternate path, yeah, to inform the neighbor, do you have alternate path? If yes, then share with me as well. If you have learned the path via me, then uninstall it from your table also, right? Because metric from my side is maximum now. And then in the response of query message, order is going to generate reply message. So in the CCNA syllabus, you will see OSPF fundamentals like types of messages, link LSAs, routers, types of areas. After that, the basic configuration, how to configure OSPF, how to change hello time, network type, right? So in the configuration, single area OSPF configuration means running OSPF routing protocol on multiple router in same area, right? We have areas concept, guys, don't worry, we will discuss it in the upcoming days. Then OSPF network type. In OSPF again we have multiple types of network like broadcast network, non-broadcast network, point to point, point to multi-point, and according to your requirement you will choose network type. Like if I am running OSPF between two router, right, both router are directly connected with each other, then my network type should be point to point. If means network type depends on topology type. Network types depends on topology type in OSPF. If you have hub and spoke topology, then your network type is going to be different. It will be point to multi-point, because one point means hub router is connected with multiple spoke routers, multiple branch offices, right? So network type is going to be point to multi-point, point to point when there are two router. Then broadcast, if multiple routers are connected with same segment, like there is one switch and we have, let's say, four router like this. So in this scenario network type should be broadcast. Then non-broadcast, where we should use non-broadcast network type. And guys, if your network type is incorrect, let's suppose here in this scenario if you will configure non-broadcast network type, then OSPF will not work fine. If you will configure network type point to multi-point in this scenario, OSPF is not going to work fine. So OSPF network type depends on topology type. You are going to implement OSPF in which type of topology, which type of network, right? So these are syllabus of CCNA. Then configure OSPF on router, configure OSPF router ID. What is router ID? Then OSPF network statements, OSPF neighborship. Neighbor relationship means again parameters, like in EIGRP. What are the parameters, guys, for neighborship? What are the neighborship parameter in EIGRP? AS number must match, router ID must be unique, subnet mask must match. Then if you have configured the authentication, then authentication should match, key values should match. These are the hello parameters. In the same way in OSPF also we have some parameters that should be must match to form neighborship. And in EIGRP we have only one types of neighbor, but in case of OSPF we have two types of neighbor. Neighbor without adjacent means two router can only form OSPF neighborship, but it will not exchange the routing information. And OSPF neighborship with adjacency means neighbor with routers will exchange routing information, right? So there are two types of neighborship in OSPF, and these are the syllabus of CCNA. OSPF neighbor establishment, OSPF states, like how two routers are going to, whenever two router will form OSPF neighborship, it will goes through these all states. In EIGRP, once you will enable EIGRP on an interface of router will start sending hello message from that interface, right? And when router will receive the hello message, it will check some parameters. If parameter will match, both router will become neighbor. But in case of OSPFC, we have multiple states. So we are going to learn these all states, don't worry. Then again, hello time means after what interval of time router will send hello message, and dead interval means hold down time. Whenever a router will receive hello message, for what time router is going to hold that information, right? OSPF adjacency, as I told you, there are two types of neighbor: neighbor without adjacency and neighbor with adjacency. So neighbor with adjacency is known as OSPF adjacency. Then metric calculation, how to calculate metric, like in EIGRP, formula is 10 raised to power 7 upon list bandwidth plus total delay upon 10 whole multiply by 256. In the same way, how you are going to calculate metric in case of OSPF, how to modify the metric calculation. Then authentication, how we can secure the OSPF routing protocol. right? So as I told you, we'll discuss security means authentication configuration of each routing protocol in security part. So here also we will not discuss the authentication, but you can see this is part of CCNA. So these all basic points are part of CCNA syllabus, right? Then see some advanced topics of OSPF, like OSPF in CCNP. So in CCNP you are going to learn advanced OSPF concept like multi-area configuration. Multi-area configuration, OSPF area type, st standard area, stub area, totally stub, not so stubby area, and NSSA area. So these are area type in OSPF. We will discuss these all, and guys, again, these are advanced concepts and you have to learn it to configure or implement OSPF in the real time in the company network. Then inter area routing, how to make communication between two different area, how to troubleshoot OSPF between two different area, the differences between forming neighborship of OSPF within area and between area. Like I have three routers R1, R2, R3. If these all routers belongs to same area, let's say area 0, and R1, R2, R3, this time these two routers belongs to, let's say, area 0, and these two routers belongs to area 1, different area. So what will be the difference in this scenario and this scenario, right? That is inter area routing. Then OSPF LSAs type, we have multiple types of LSAs in OSPF. These are nothing but kind of messages in OSPF, okay? So these are again advanced concept and you need to learn it. We have actually 7 types of LSAs here, right? So we'll discuss all LSAs. Then OSPF network design, hierarchical architecture for OSPF, OSPF area design, OSPF summarization, like how we are going to summarize the route in OSPF. In EIGRP, you know how to summarize by running command IP summary address for EIGRP, yes number, and then summary address and subnet mask. This is how we are summarizing route in EIGRP. But the summarization concept is different in case of OSPF. Then guys, timers like hello time, hold on time, how to change it, like according to your requirement, how you can optimize the OSPF. Then OSPF troubleshooting, common issues in OSPF, use some debug commands and verification command. Then virtual link, OSPF virtual link concept, you will understand why we need virtual link, in which scenario we need to configure virtual link. But nowadays we are generally not using it, but this is part of your syllabus, so definitely we will cover it. Then again, redistribution, how to redistribute EIGRP or other routing protocol in OSPF. You know now, till now you know how to redistribute any other routing protocol in EIGRP or in RIP, right? Now you are going to learn how to redistribute EIGRP into OSPF and OSPF into EIGRP or in any other routing protocol. So redistribution concepts. Then guys, CCIE. These are parts of, yeah, recording on. See, recording is on. Please focus on content, okay? Because I must tell you, it is very important. Even if you will go for interview will ask you question from OSPF and BGP only. They are not going to ask you question from EIGRP, okay? So keep these all things, unnecessary things aside for a moment. Don't worry, if I will not record the session, then also I have already recording. I will share the recording with you, okay? Focus on content only, right? And let me focus on content only. These are part of your CCNP syllabus. Now then, advanced certification, expert level certification, that is CCIE. So we have some topics of OSPF in CCIE. I want to discuss those topics as well in this live session. It will help to get job easily, because as I told you, interviewers are going to ask question from OSPF routing protocol only. So in CCIE, actually you are going to learn in-depth OSPF analysis, right? Depth troubleshooting, depth configuration. According to your requirement, you can understand which routing protocol is going to be best for my network, right? So now we have some in-depth concept of OSPF, like OSPF protocol mechanism and internal operation. OSPF is a protocol, means like operating system. So we are going to learn this operating system. You can assume OSPF is a operating system and how these operating system works. Then detailed information of OSPF database and SPF algorithm. EIGRP uses dual algorithm to calculate best path, to find best path. In the same way, OSPF uses SPF algorithm, shortest path first, to find best path. Like guys, in EIGRP, what will happen? Whenever a router will receive update message, it will install that all network information in their topology table, and on their topology table, it will EIGRP will run dual algorithm, and with the help of dual algorithm, it will find best path, and then it will install best path in their routing table. In the same way, OSPF is going to maintain database, and on their database, it will run SPF algorithm. And with the help of SPF algorithm, it will find best path and then it will install in routing table. So how SPF algorithm works, right? Advanced OSPF design and implementation, large scale OSPF design, complex OSPF area design, OSPF in MPLS and VPN environment. Just wait a minute. Guys, here in the live class, we are connecting 2 routers or 5 routers, 10 routers directly with each other. But in real time, why you are going to connect 2 routers directly, right? Like this, R1 and R2. Why you will connect 2 routers like this, right? Maybe if I need redundancy, I have one network design like this. Multiple access layer switches are there, few distribution layer switches are there, like this, and then router. So for redundancy, I am using 2 routers, R1, R2. I can connect like this, and then I can connect these routers to internet. Maybe this can be my scenario. Here, see, I am not connecting 2 routers together, right? But whenever I am connecting 2 routers together like this, R1 and R2, just assume this is one branch office or headquarter or data center, right? This is another branch office, and both routers are connected through transportation technology. Again, we have multiple transportation technology like internet, MPLS, SD-WAN. These are transportation technology, overlay network, right? So with the help of transportation, we are going to connect multiple sites together. And now, if suppose 2 branch offices are directly connected together with the help of internet, right? Like this. This is, let's say, in India, and this is, let's say, in US. So this is my private network, right? This is my private network. This is public network. So 2 private sites are connected together with the help of public network. And by default, 2 private network cannot communicate with each other through public network, right? 2 private network cannot communicate over public network. So the technology which we are going to use to make it possible is known as VPN, right? Here, our public network, I can create one virtual private network. That is VPN technology. We will learn it later. So configuring OSPF between 2 routers if they are directly connected, or configuring OSPF between 2 sites which are connected through public network. What is the difference? What are the differences in this scenario and in this scenario? right? How OSPF is going to behave in this scenario? How OSPF is going to behave in this scenario? First we will learn OSPF over here between two router, then OSPF behavior over VPN. Done. So OSPF in MPLS VPN environment, and OSPF, see, we are not only using OSPF in internal network, right? Like if you are thinking that we are using OSPF is an IGP protocol, means interior gateway routing protocol, that means we are using it inside the network, right, for the internal communication. Like maybe enterprises can use OSPF in their internal network. No, OSPF is widely used routing protocol. Service providers are also using this routing protocol, right? Service providers are also using OSPF routing protocol because it is an open standard routing protocol, means it is compatible with different vendor devices. At the same time, OSPF can manage large network. So these are advanced concepts of OSPF that I will cover in the class if you guys will pay attention, right? If you guys will learn OSPF basic very well. Because until and unless your basic is not as strong, I can't teach you, right, advanced things. So I will start from the zero. I will go very slowly. You can stop me anytime. Even I can explain one single topic for 10 times, right? No problem at all. But you have to show me the interest that you want to really learn, right? Then OSPF multi-area deployment, how we are going to deploy OSPF. Like let's take one example of a company, XYZ company. The company is XYZ corporate, right? This is a corporate company who have multiple branch offices, headquarter in India, right? And then this company have multiple branch offices, and all branch offices are connected through headquarter. So in this scenario, if I will talk about the OSPF configuration, I am going to configure multi-area OSPF. Here I will configure OSPF area 0. Here I will configure OSPF area 1. Here 2. Here 3. Here 4. This is a real-time use case, right? I'm telling you guys, this is how we are configuring OSPF in real time in the XYZ company. So why I am using multiple area here? Why I have advertised headquarter in area 0? Why branch 1 in area 1? A branch 2 in area 2, in area 3, in area 4? What are the reason, right? So we'll make you understand everything from the zero. Don't worry. And these are the advanced configuration. These are the advanced topics of OSPF. You have to understand the requirement. Why I am configuring OSPF like this? Why not I am advertising entire network in single area, right? So these are part of CCIE, where you are going to learn the OSPF multi-area deployment. Why I'm going to deploy multiple area of OSPF. OSPF multi-area design and optimization, how you are going to optimize the network. OSPF area types and advanced features. Then again, security. As I told you, OSPF provide authentication feature. So until and unless we will not understand the basic fundamentals of security, now you understand the basic fundamentals of routing and switching, right? This is why I'm able to teach you routing protocols. In the same way, until and unless you will not understand the security fundamental, I cannot teach you security, right? So that's why I'm keeping the authentication part separately. First we'll cover the security fundamental. After that we will see these authentication configuration or concept. Advanced OSPF authentication and security mechanism, OSPF security best practices, then high OSPF high availability, right? Redundancy. How to configure or implement deploy OSPF for high availability, right? Because let's suppose for a company priority can be cost, priority can be availability, priority can be scalability. Means according to the future growth, my network should be scalable, right? My network should be capable to handle more user, or I should be able to extend my network. So according to the priority, we are going to configure protocols or OSPF routing protocol, right? According to the priority, we are going to design the network. According to the priority, we are going to configure the protocol. Let's suppose a company, again XYZ company, need to connect their clients, and these clients should be able to communicate with each other, as well as these clients should be able to access internet. This is the requirement. But main priority of this company is cost. This company is not interested to invest lots of money on their network infrastructure, right? So for this company, availability is not the priority. Priority is cost. This company can manage network downtime, right? So here I can use a single router and I can connect this to the internet. Still we have issue if this in ISP will goes down, these user cannot access internet. But as for this company, priority is the cost. So this company can manage it. Likewise for me, see, I am teaching people. Let's say today my internet is not working, right? My ISP is down. No problem, simply I can put one message in WhatsApp that we have some technical issue, we'll postpone the class, right? Here I don't need to purchase one router, right, for the redundancy. One router is already there. But suppose I'm running some critical software, critical application, even at my home, then this network is not sufficient for me. Then my priority is availability, redundancy. So I am going to add one more router here, more ISP here, right? So if one ISP will goes down, then also we will have internet connectivity. So everything depends on our requirement, our priority. If priority is availability, then there should be redundancy, and you have to configure OSPF here in such a way so that it should use always primary link. But if primary link is not available, then it should automatically shift traffic on secondary link. Let's say this is my primary, R1 is the primary router, because here we have 40 Gbps or 10 Gbps, 10 Gbps, right? But R2 is the backup path. Here we have 100 Mbps link for the backup, right? Whenever ISP primary link will goes down, users should be able to access internet via secondary link. So now in this scenario, you need to implement OSPF in such a way so that OSPF should always forward traffic towards ISP1. But if ISP1 will goes down, or this link will goes down, or order will goes down, automatically OSPF will start forwarding traffic towards ISP2. So there is concept of OSPF in high availability design. How to design for high availability. After that, OSPF fast convergence and failover, like as I told you, failover. How to configure the load balancing. Let's say between ISP1 and ISP2, I want to achieve load balancing, right? I want to forward 50% traffic to ISP1, 50% traffic to ISP2. Or I want to configure active and primary and secondary scenario, right? Active and passive scenario, you can say. That is failover. That if my primary link is down, then it should automatically fail over the traffic, should shift the traffic on secondary link. Advanced concept. Then OSPF with IPv6. So till now we didn't discuss anything about IPv6. So when I will discuss IPv6, we'll implement all dynamic routing protocols like EIGRP, REAP, OSPF with IPv6. Then you will learn how to configure routing protocol with IPv6 in the IPv6 network, right? So these are IPv4 and IPv6. These are what, guys? These are address family. IPv4, IPv6, Apple Talk. These are address family. So for different address family, we can configure routing protocol, right? So right now we are learning how to configure routing protocol for this address family, for IPv4 address family. After that, OSPF performance tuning, OSPF performance tuning technique, OSPF load balancing, OSPF troubleshooting at scale, advanced OSPF troubleshooting technique, OSPF case study, and real world issues. So as I told you, I have experience on this routing protocol. I have real-time experience on this routing protocol. Whatever issues or troubleshooting I have faced in real time, I am going to share all scenario with you. But to understand those scenario, you have to learn all basic concept very carefully of OSPF, right? Then if I will talk about the syllabus of OSPF, now we don't have anything. Like you can see, OSPF interaction with other routing protocols like BGP, EAGRP, and ISIS. Will not cover ISIS, but this is also one protocol. Then OSPF route filtering. We'll see the route filtering in the same way like EAGRP. How we have filter route in EAGRP, in the same way we are going to filter route in OSPF also. Then OSPF lab practice. We'll see some companies network, right? Complete companies network. So how we are going to configure OSPF there. Then complex OSPF lab scenarios and on OSPF configuration and troubleshooting lab. After that, difference between link state and distance vector and link state routing protocol. You already know the difference, right? I'm not going to discuss it over here. First is method of operation. Like distance vector routing protocol perform routing by rumors. Means all routers are dependent on their neighbor. A router don't have complete information of topology. Like I have a topology like this: R1, R2, and R3. Here I have one LAN X, here I have one LAN Y, here I have one LAN Z. So router 1 is going to advertise X network to router number 2. Router 2 is going to advertise X and Y network to router number 3. And router 3 is going to advertise Z network. Router 2 is going to advertise Y and Z network to router number 1. So in the distance vector routing protocol, router 1 will have only information about this network, that these networks are available to my neighbor. See, who is advertising Y and Z network to router number 1? Router number 2. So router 1 knows these networks are available on router number 2. But suppose there is one alternate path available, right? R4, R5. R1 is connected with R4 also and R3 also. In this scenario, router 4 will also advertise Z network and Y network to router number 1. But router 1 will not accept it because it is receiving best path from router number 2 with lower metric. So router 1 don't have information about the upper path, right? If upper path is not feasible successor in EAGRP, then router 1 is going to install only best path via router number 2. And if link will goes down, if this network will goes down, directly router 1 will generate query message to their neighbor, right? This is what routing by rumors. Router are dependent on their neighbor, right? Router don't have information of complete topology. But OSPF routing protocol is like Google Map. In the map, if you will find way from, let's say, Mumbai to Delhi, it will show you lots of available path, right? All possible path, all available path. In the same way, if we are running OSPF routing protocol over here, router 1 will have information that there are two paths to reach in Y and Z network, but best is via router number 2. But if router 2 will goes down, I know the alternate path as well. I can install the alternate path in my routing table. So a router will have complete information of topology. This is the first difference between distance vector and link state routing protocol. Should I discuss, guys, differences between the distance vector and link state again, or I can start directly OSPF routing protocol now? Tell me. Hey, am I audible? Sorry. Again, distance vector and link state, the difference between these two protocol. Okay. See, the first difference is clear. Routing by rumors in the distance vector routing protocol. Distance vector routing protocol. First issue is routing by rumors. Distance vector routing protocols operate by exchanging routing information with directly connected neighbor. Each router sends entire routing table to its immediate neighbor periodically. This is behavior of distance vector routing protocol. Distance vector routing protocol calculate best path on the basis of hop count. Convergence. Convergence is slow in case of distance vector routing protocol. Slower convergence. Distance vector protocol can suffer from slower convergence times. Remember the RIP routing protocol, guys. Flush time is 240 seconds. Even a network information will goes down, right? Router is going to keep that information in their table for 240 seconds, right? So that means convergence is very slow in case of distance vector routing protocol. So it is going to be reduce the network performance in large network. And there is issue of loop as well. That's why we have some features there like a speed horizon, route poisoning to avoid the loop. If I will talk about the algorithm, so distance vector routing protocol uses Wellman-Ford algorithm. Most distance vector routing protocol use Wellman-Ford algorithm. Dual is also one type of Wellman-Ford algorithm to calculate best path. Example of distance vector routing protocol is RIP IGRP. Nowadays we don't have this protocol, but earlier, guys, we had this protocol IGRP. In the dynamic routing protocol, earlier we had RIP, IGRP, EIGRP, right? But nowadays we don't have IGRP. Interior gateway routing protocol. Actually, EIGRP has replaced this routing protocol, right? So these are example of distance vector routing protocol. Then in the distance vector routing protocol, if I will talk about the routing information exchange, so guys, routes exchange periodically, right? Periodic updates. Router send updates at regular interval regardless of changes in the network. Routers should only send their database their complete information whenever change will occur, right? When change will occur, it should send the update message. But in the distance vector routing protocol, it will send periodically. Then second issue, entire routing table, right? Again, it should send only changed information, not entire routing table every time. Because if routers are sending the entire table, right, entire routing table, guys, size of that update message will be large, right? So each router sends entire routing table to its neighbor periodically. Complexity, right? But distance vector routing protocol, good thing about distance vector routing protocol is it is easy to configure, it is easy to manage, right? So it is simpler configuration as compared to link state vector routing protocol. Easier to configure and understand due to their simplicity. See, I have teach you RIP and EIGRP, both routing protocol, I think in 5 to 6 days. But now I am going to take maybe 10 days for single protocol like OSPF, right? So definitely distance vector routing protocols are easier than link state routing protocol. Metric calculation, again issue hop count only. Escalability, there is hop limit, right? In RIP, you can connect up to 15 router. In EIGRP, you can connect up to 255 routers, right? Which limits the size of network. So we have scalability issue here. Then link state routing protocol. But if I will talk about the link state, so see guys, the method of operation. All router will have complete network topology, right? Link state protocol operate by having each router create a complete map, right? We will see what we can do to check this. Simply I can draw a diagram like this: R1, R2 and R3. Here I have one LAN, here I have one LAN, and here I have one LAN. Then we'll hide the diagram with the help of console, with the help of the configuration. We'll try to design the same diagram. Then you will see how a router can design complete network by checking their database, right? So a router in OSPF, in link state routing protocol, can design the entire topology by checking their database. But EIGRP protocol cannot design, right, entire topology, because EIGRP routing protocol knows their neighbor only, right, who have advertised the network. It knows two router, successor, two paths, successor and feasible successor. That's it. So this is first biggest advantage of link state routing protocol. And it can be disadvantage as well, right? Because if all routers are going to maintain the entire topology, entire database, then definitely it will use more CPU, right? So CPU utilization in link state routing protocol is higher as compared to EIGRP. Done, guys. Convergence. Convergence is fastest in case of OSPF. We will see how link state routing protocol is faster than distance vector routing protocol. Convergence is fast and more stable. In EIGRP, again we have issue with stability, right? EIGRP is not stable when router is sending query message. It will, whenever router will send the query message, it will put that network in active state in their topology table. And if a router will not get reply message within 180 seconds, then it is going to break the neighborship. That means EIGRP is not a stable routing protocol. Getting my point? Right? So, but link state routing protocol is stable and their convergence is fast, making them suitable for large and more complex network. Then algorithm, if I will talk about the algorithm in link state routing protocol, so link state routing protocols use Dijkstra algorithm. OSPF uses SPF algorithm, shortest path first algorithm, right? Dijkstra algorithm uses link properties to calculate best path, right? To calculate the shortest path, to each destination. An example of link state routing protocol is OSPF ISIS, right? ISIS is very advanced routing protocol. Generally, we are using it in ISP's network, right? Service provider network. It is not for enterprises. Then routing information exchange. How link state routing protocols are going to exchange routing information? With the help of trigger updates. So first time router will send complete route information, complete information of their links, but it will not send periodically. After that, it will send update message whenever change will occur in the topology. And when change will occur, then also it will send partial update message. Means only changed information, not the entire things. So trigger update. Router sends update only when there is a change in the network topology, reducing unnecessary traffic like distance vector routing protocol. Router exchange LSS to inform other router about the link complexity. But link state routing protocol is more complex as compared to distance vector routing protocol. More complex configuration, right? More complex to configure, understand due to the requirement of maintaining a complete network topology, as routers are going to maintain a complete network information, right? Complete information of their topology. So let's suppose I'm talking about a network XYZ corporate network. In their XYZ corporate network, there are 1000 routers, right? So all routers are going to manage same database. Database of all 1000 router will be identical, same, right? Then metric calculation. Metric depends on Link properties like delay, bandwidth, scalability, high scalability. Link state routing protocol is high scalable, highly scalable and suitable for large and complex network. Now there is one diagram. You can see the differences. Now question is where to use OSPF. By the way, I should discuss this point where to use OSPF after discussing the basic thing. But okay, if the topic is in front of me, then let me discuss something about this also. See guys, where to use OSPF routing protocol. Types of network that use OSPF. OSPF is widely used in various type of network due to its scalability, fast convergence, and support for complex topology. Here are some common. You can see enterprises networks. Enterprise network, large companies with multiple branches, campuses, and data center, right? So a enterprise company, a large enterprise company with multiple branches, campuses, and data centers can use OSPF routing protocol, right? Then service provider networks, ISPs and telecom companies that need to manage large hierarchical networks. Then campus networks like campus area network to connect multiple buildings. Again, a university can use OSPF routing protocol. Educational institution can use OSPF routing protocol, right? So university and large educational institution with complex and multiple building infrastructure, right? Then in data center, let's say you have 10,000 servers in one data center, or maybe you have multiple data center, right? So there also you need a scalable and stable routing protocol. You will use link state routing protocol there, right? Now just I am trying to make you understand the use case of OSPF network types for OSPF, suitable network types of for OSPF. When I will start the BGP guys, I will filter it. You will easily understand, okay, in this type of network I should use BGP. Oh, like that, right? So data centers, reason for using OSPF, what are the reason? First reason, scalability. Second reason, fast convergence. Link state routing protocol, it is a link state routing protocol means we'll have complete information. OSPF maintain a complete map of network, allowing for more efficient and accurate routing decision compared to distance vector routing protocol like RIP. Then OSPF support VLSM and CIDR. Multi-vendor support. As OSPF is an open standard protocol, we can, let's suppose I have two router, right? I have two router, one in branch 1 and this is Cisco router, and one in branch 2 which is Juniper router, right? So here we need open standard routing protocol, right? Here we need open standard routing protocol, and OSPF is an open standard routing protocol. So because of this multi-vendor supports, OSPF is widely used routing protocol. OSPF is an open standard protocol supported by various vendors, ensuring interoperability in multi-vendor environment. Then authentication, as OSPF support authentication to secure routing information exchange. So these are the benefit of using OSPF. Now if you want to see the comparison between OSPF and other routing protocols, see EIGRP. EIGRP commonly used in Cisco network, but earlier EIGRP was Cisco proprietary, but nowadays EIGRP is also open standard routing protocol. We can configure it on Cisco devices as well as on non-Cisco devices. Earlier EIGRP was Cisco proprietary. Done. So EIGRP Earlier Cisco was using EIGRP. Whenever you need unequal cost load balancing, whenever you need unequal cost load balancing, then you will use OSPF. Or if your priority is CPU, like as I told you, OSPF is going to use more CPU than EIGRP. So again, if CPU is your priority, then you can use EIGRP protocol, right? So you can see the pros and cons. EIGRP fast convergence, easy configuration, support unequal cost load balancing. But OSPF is slow protocol as compared to EIGRP, right? Slow, hard configuration, and does not support unequal cost load balancing, OSPF. So hope now you can understand the scenario where we need to configure EIGRP. Earlier it was Cisco proprietary, so you can see this was the disadvantage, but nowadays it is also open standard, but not other vendors are mostly using EIGRP. Okay, let's support by 4 multi-vendor equipments. Again, see, the issue is now EIGRP is Cisco proprietary protocols, not open standard protocol, but most of the features of EIGRP is Cisco proprietary. Most of the features of EIGRP is Cisco proprietary. You can configure EIGRP on other vendor devices, but you cannot utilize the complete features, right? Then other protocol can be BGP. So BGP used in routing between different autonomous system, right? Between different AS, between different companies network, like between XYZ corporate and ABC corporate, typically on the internet in large scale WAN environment. So when we will learn the BGP, when we will start the BGP, we'll see the scenario for BGP. Probes of using BGP over OSPF. In the BGP, the biggest advantage is policy based routing. We have lots of options to manipulate the path, to configure policy based routing, right? According to our requirement, we can manage the protocol. Like in EIGRP, if you want to manage the path, right, between source and destination, there are 10 number of paths. So if you want to manage it, you have again multiple options, right? Like unequal cost load balancing means variance, you have offset list, you have bandwidth, delay. By using these things, you can manipulate the path. But when you will when you will learn the BGP, you will see there are lots of attributes available, right? So according to the requirement, we can manage the routing protocol, which routing protocol? BGP, right? So BGP is more flexible routing protocol as compared to OSPF for policy based routing, right? Even BGP is more flexible than any other routing protocol in terms of policy based routing, right? Support for multiple routing policies. And disadvantage can be complex configuration, complex concept, slower convergence. Even BGP is much slower than OSPF. BGP is much slower than OSPF and EIGRP. Okay, then RIP. Nowadays we are not using it, but again you can use it in the small network, because configuration of RIP is very simple, right? Configuration and management. So it is suitable for a small network and you can configure it. A multinational corporation with headquarters in New York, France, branch offices in headquarters in New York, branch offices in London, Tokyo, and maybe India, somewhere else, US, will use OSPF. How? Multi-area OSPF, right? As I told you, you will advertise headquarters in area 0. You can put entire router in headquarters in area 0 and all branch offices router in different areas. So you can see headquarters using this subnet, and I'm going to run OSPF area 0. OSPF, in OSPF we have multiple types of area, and you will learn area 0 is the backbone area, main area of OSPF, right? Then I can advertise branch offices in different area. Actually, we have two types of area in OSPF. We have again several types of area, but first we categorized area into two part. One is backbone and internal. Backbone means area 0 and internal area means any area except area 0, like area 1, area 2, area 3, area 100, area 500. These are internal area, regular area you can say. So backbone area is the area 0, right? For data center we have this subnet and we can run a different area for data center, again area 0 and area 4 and 5, let's say. So these are some basic concepts of OSPF. Now guys, without wasting our time, let's begin. Let's start the OSPF routing protocol. Before that, I would like to ask you, if you have any question, please ask to me. Otherwise, now I am going to start OSPF from the zero. Yes. Yes guys. Any question? No? Yes? Not RIP, brother. According to EIGRP, RIP is an pure distance vector routing protocol. EIGRP is combination of link state and distance vector. OSPF is faster than RIP. Okay. So first point about OSPF routing protocol is, let me write here. If you have notebook, you can write these points, like basic point for interview. First thing is OSPF stand for open shortest path first. Then it is an open standard protocol. Then it is an IGP protocol. What is the meaning of IGP? Hello. Yes, what is the meaning of interior gateway routing protocol? It works within AS, within autonomous system number, right? Between AS, OSPF is not going to work, right? So again, within organization we can use OSPF routing protocol. Between two organization, between XYZ and ABC corporate, we will not run OSPF protocol. So it is an IGP protocol, then it is an link state routing protocol. Yes. Link state protocol. Then what can be the other point? Link state routing protocol. Classless. Yeah. Classless routing protocol. Yeah. It is an layer 3 protocol. What is the protocol number? If it is layer 3 protocol, then definitely this protocol will have one protocol number, because it not uses TCP or UDP. So it uses protocol number 89. Very good. Then it uses two multicast address. It uses two multicast addresses, which are 224.0.0.5 and 224.0.0.6. Now question is why OSPF uses two multicast address. Don't worry, we will see. Actually, all router in OSPF domain will listen this IP address. Like guys, if I have a router R1 F0/0 and on this interface IP address is 10.1.1.1. To enable EIGRP routing protocol, you are going to run command router EIGRP ES number, let's say 10, and the network 10.1.1.0. Once I will hit enter, what will happen? This interface will join a multicast group. Which multicast group? The multicast address which is reserved for EIGRP. In the same way, whenever you will enable OSPF on the interface of router, that router will join two multicast group, right? This one and this one. But all router will listen for this IP address 224.0.0.5, and this IP address is for different purpose, for DR and BDR. Now if you are thinking what is DR and BDR, why we have this multicast address, don't worry, we will see it. Okay, but for now just keep in mind OSPF uses two multicast address, and by default all routers listen on this multicast address. Like in EIGRP we have 224.0.0.10, so all routers listen on that multicast address. In the same way all routers in OSPF listen on this multicast address .5. Then it uses SPF algorithm to find best path. Then metric calculation. Metric in OSPF is cost, and formula to calculate cost is reference bandwidth upon bandwidth of link, right? So let's suppose again a router have one interface F0/0 where IP address is 10.1.1.1. Once I will enable OSPF on this interface will join the multicast group, and then router is going to calculate cost for this network. How it will calculate cost? Reference bandwidth upon bandwidth of link, and by default reference bandwidth is 100 Mbps. By default reference bandwidth is 100 Mbps. We can change this value, right? But this is by default value. And guys, bandwidth of fast Ethernet link is 100, so cost will be what? 1 over here, right? If this is a Ethernet link, then it will divide reference bandwidth by bandwidth of their link. So bandwidth of Ethernet link is 10 Mbps, so cost is going to be what? 10. This is how OSPF calculates metric. So let me write the default reference bandwidth value. Default reference bandwidth is 100. Then anything else? So cost on serial link will be what? Actually cost on serial link is going to be 64, right? Cost on the fast Ethernet link is going to be 1. Cost on fast Ethernet link is going to be 1. And cost on fast Ethernet and cost for Ethernet link will be what? Yes, 10. So like this you can calculate the cost on any link with the help of bandwidth. Now types of messages in OSPF. Types of messages in OSPF. So first message is type 1 message. Type 1 message, and name of type 1 message is hello message. So if someone will ask you what is the type 1 message in OSPF, that is guys hello message. Second, type 2 message. Type 2 message is DBD message, database description. Third message is type 3 message is LSR, link state request. Don't worry, we are going to learn the use of these all messages like EAGRP. In EAGRP you know the use of each message. In the same way here you need to learn the use of all these messages: hello message, DBD message, LSR message. Then type 4 message. Type 4 message is LSU message, link state update message. Then fifth type of message, that is type 5, and type 5 message is LSAC, link state acknowledgement. So how many messages are there in OSPF? 5. Done guys? Clear? Now hello message. Hello. So hello message, to discover, first use is to discover neighbor, like EAGRP, to discover neighbor and keep alive. Done. And router always send hello message on multicast address. Multicast address in case of dynamic neighborship. Again we have two types of neighborship in OSPF, static and dynamic. So in dynamic neighborship, OSPF will send hello message on multicast address. On what multicast address? 224.0.0.5, right? All routers listen this multicast address, so that's why router will send multicast address, hello message on this multicast address. But hello message will be unicast in case of static neighborship. Static neighborship like EAGRP. Done. If I will talk about the contents of hello message, what information hello message is going to carry. So contents of hello message, contents of hello. First information is again version, but that is not important for you. What is the version of OSPF? Then there will be type of message, opcode, types of message. So hello message is type 1 message, right? So type code will be what guys? 1 here, right? So types of message, that will be 1, means it is type 1 message, type 1. Then there will be information about the router ID, and today we are going to learn the router ID as well, router ID. Then hello message will carry authentication information, authentication type. We have multiple types of authentication in OSPF. So authentication type will be there. Authentication type. Then authentication data means the password. Authentication data. Then what rest information will be there? Subnet mask. Subnet mask. Then hello time and date time. Hello time and date, time. Then see, OSPF hello message is going to carry multiple information, guys. Priority will be there. Priority. We will see what is the concept of these all point one by one. Don't worry. Priority information. Then there will be information about DR router ID. DR router ID. DR router ID. Don't worry if you don't know the DR router ID. Then next information can be DR low BDR router ID will be there. DR and BDR. Let me say DR and BDR. Designated router and backup designated router. Then most important information, that is neighbor router ID. Neighbor router ID. So OSPF hello message is going to carry these all informations. Clear? Yeah. Go ahead. R1, R2. Command to configure OSPF on router number 1 is router OSPF, then process ID, after that network command. So with the help of network command, we can enable OSPF on interface, right? That is, guys, dynamic neighborship. If I will advertise this interface F0/0 of router 1 and F0/0 of router 2 with the help of network command, will these two routers form neighborship? Yes. And which type of neighborship? That is dynamic neighborship. But in EIGRP we have seen we have option to configure a static neighborship as well. Like on router number 1, manually I can say neighbor. Under router OSPF 1 I can say neighbor and then IP address of router 2. IP address of router 2. IP address, destination IP address. In this case, router 1 is going to form a static neighborship. In this scenario, you have to configure neighbor command on both router, on router 1 also and on router 2 also. And both routers are going to form a static neighborship. So whenever router will form a static neighborship, in that case, router will send hello message on unicast address. Clear? Okay. Now, out of these information in hello message, what are the parameter for neighborship? What are the parameters for neighborship? So guys, like in EIGRP, ES number, key values, subnet mask, these are authentication data. These are what hello parameter. In the same way, for OSPF, neighbor parameters are neighbor parameter. Neighbor parameters are first router ID. Router ID must be unique. Router ID must be unique. If on router number 1 and router number 2, if you have configured the same router ID, these two routers are not going to become neighbor. So first parameter is router ID must be unique. Second parameter is hello and hold on. Hello and hold on time. Timer must match, right? So let's say hello time on router number 10 is 1 is 10 second and hold on time is 40 second. So same hello time and hold on time should be configured on router number 2 also. Then only OSPF will form neighborship, right? Third parameter is router ID must be unique, hello time and hold on time must be match subnet mask, subnet and subnet mask must match. Fourth, MTU must match. MTU must match. Even you can ignore the MTU, but additionally you have to configure it. You have to run one command to ignore the MTU. But by default, MTU is a part of OSPF neighborship, right? So MTU must be match. Then fifth one is authentication type and authentication data. Authentication type and authentication data must match. Then there are some flags in OSPF. We will learn about those flags. So stub flag must match, area ID must match. Leave flag for now because I don't want to confuse you, but when I will discuss the flag I will tell you flag should also match, flag bit should also match. Then area ID must match, so on router number 1 and on router number 2, if area ID is different, then again these two routers are not going to form neighborship. In EIGRP, AS number should be match. In OSPF, area ID should be match, right? Then 7, next parameter, network type. As I told you, we have multiple types of network: broadcast, non-broadcast, point to multi-point, right? So network type should also must match. Network type must match. These are hello parameters. Now you can take one a screenshot of it. Please take one a screenshot. Done, guys? These are hello parameter. Now let me verify these all. What I'm going to do, I'm going to take two router here, R1, R2. Let me connect these two router together. Is topology visible? What network I am going to use between router 1 and router 2? 12. Between router 1 and router 2, I am going to use 12 network. Let's say 12.1.1.0/24.1 on router number 1, .2 on router number 2. And before configuring it, let me discuss one more thing, that is router ID, right? So what is router ID, guys? Router ID, as I told you, router ID must be unique on both router ID. Concept of router ID is same in EIGRP as well as in OSPF. This is why we didn't discuss router ID in OSPF. Now try to understand the router ID. It is an 32 bits unique. If it is 32 bits, that means you can find the range, right? It is 32 bits decimal, unique decimal number used to identify router, used to represent database of OSPF, right? So it is an 32 bits unique, we can say, identification of router in OSPF. 32 bits unique identification in OSPF domain, we can say, in OSPF domain, right? So let's suppose I have again two router R1, R2. Guys, as I told you, both routers are going to share their complete information. As OSPF is link state routing protocol, so router 1 is going to share the state of their all links to their neighbor, to router number 2, right? So let's suppose router 1 is connected with multiple links, 0/0, 0/1, 0/2, 0/3. So router 1 is going to share a state of these links to their neighbor, right? First of all, router 1 is going to maintain one database. In the database, router 1 will add their link state state of each link. Fast Ethernet 0/0, 0/1, 0/2, 0/3, right? There will be many information like all states of the link. Now how router 1 is going to represent this database with the help of router ID. So let's suppose router ID is 1.1.1.1. So actually this router ID is unique identification of their database. In the same way, router 2 is going to maintain database and their router ID is 2.2.2.2. So router 2 is going to represent their database in entire OSPF domain with the help of this router ID, and router 1 is going to represent their database in entire OSPF domain with this router ID, right? So unique identification of router in OSPF domain. If we have 100 number of routers in OSPF domain, so all 100 routers will have unique router ID. Now how to configure the router ID? How router elect router ID? How router elect router ID? So two options. We have two options, guys. To configure IP address on a device, we have two options. Either I can configure manually or I can configure what? DHCP. In the same way, to configure router ID on router, we have two options. First one is manually. Manually you can configure, this is your router ID, right? I can say router 1, listen, 1.1.1.1 is your router ID. As it is 32 bits, so representation is also in format of IPv4 address, right? So representation of router ID is in format of IPv4 address. So manually we can say your router ID is 1.1.1.1, or it can be 255.255.255.255, right? So from 0.0.0.0 to 255.255.255.255, any router ID you can configure on router manually. But what if you will not define router ID manually? Then router is going to select automatically, right? That is dynamic method. Now question is how router is going to select router ID dynamically. So as you know, router ID is 32 bits address represented in IPv4 format. Router is going to check their loopback, right? Is there any loopback exist on the router? If yes, then the IP address which is running on loopback interface will be considered as, will be elected as router ID, right? So on the router, let's suppose we have one loopback. On the loopback, I'm running IP 1.1.1.1. So router ID of OSPF will become that IP address. What if we have multiple loopbacks on router? Let's say more than one. Then highest IP address on the loopback interface will be router ID of OSPF router, right? So first highest IP address of loopback interface. What if loopback is not exist in the router? Then guys, highest IP address of physical interface. The IP address which is running on physical interface. Again, if we have multiple physical interface, then the highest IP address. And if there is no IP address on the physical interface, like you have not configured router ID manually, there is no any loopback, and there is no any IP address on physical interfaces, but you have enabled the OSPF. In that scenario also router need what? Router ID. Because before router ID, router cannot create database. But once I will enable OSPF, router will start maintaining database. So router is going to elect 0.0.0.0 as their router ID. Clear? So here I have one router, guys, and on this router I have one physical interface. Let's say two physical interfaces are there. 1, 2. This is R1. R1 0/0, where my network is IP address is 10.1.1.1/24. This is F0/1 where I'm running IP 20.1.1.1/24, and I have some loopback on this router. Let's say loopback IP address is 1.0.0.1 and 1.1.1.1. Two loopback are there on router number 1. So now if I will run command router OSPF process ID 1, hit enter, what will be the router ID of R1? Tell me what will be the router ID of R1? 1.1. If there is no loopback, then what will be the router ID of router 1? No. Physical IP address. We have two. So router is going to elect higher IP address, this one, 20.1.1.1. But if there is no IP address on this interface as well as on this interface, then what will be the router ID? 0.0.0.0. Done. So see, in this scenario right now I don't have any IP address on router number 1. I don't have any IP address on router number 1. So if I will enable OSPF here, config T, say router OSPF process ID 1. What it's saying? OSPF process 1 failed to allocate unique router ID. So that's why this router cannot start the OSPF process. Getting my point? Router 1 is not able to elect router ID. So IP protocol. What is the router ID? Correct. Right? But always keep in mind, router in OSPF will not work with this router ID 0.0.0.0. So the other option is I can configure router ID manually, router OSPF 1, and say router ID 1.1.1.1. That's it. Now see, so IP protocol. What is router ID? But guys, once a router will become neighbor, right? Let's say router 1 have formed the neighborship with router number 2, then you cannot change the router ID. Can anyone tell me why I am not able to change router ID after forming neighbor? See, after no, what I am saying, that here router ID is 1.1.1.1, here router ID is 2.2.2.2, and these two routers are neighbor in OSPF. Now I want to change router ID on router number 2, router number 1. I want to configure 10.10.10.10. This should be the router ID on router number 1. I cannot change it. Reason? Router 1 have already shared their database to their neighbor with what router ID? 1.1.1. Right? Router have already shared their database. It have shared to router number 2. This is my database. And how you are going to identify this database? With the help of my router ID 1.1.1.1. And now you are saying to router 2, router 1, please change your router ID. No, router will reply to you, no brother, I can't, because I have already shared some information to my neighbor with previous router ID. So if you want to change the router ID, first break the neighborship. Done. Now on router number 1, I'm going to remove the router ID configuration, router OSPF 1, and say no router ID 1.1.1.1. So IP protocol. What is the router ID? So once a router will elect one IP address as router ID, even you cannot remove that configuration, right? You cannot change it, and you cannot remove it. Now I am able to change router ID. Reason, router 1 don't have any neighbor, so IP OSPF neighbor, no neighbor, right? Now let me configure the scenario. Interface F0/0 say no set, and IP address 12.1.1.255.255.0. Router OSPF 1 and network 12.1.1.0, and here in OSPF we will use wildcard mask. So wildcard mask will be what? 255, and then area, in which area you are going to advertise it. So in area 0, let's say. Now show IP OSPF interface brief. You can see show IP OSPF interface brief. OSPF is enabled on which interface? On fast Ethernet 0/0, and state is waiting. This is the state of DR and BDR. Don't worry, we will see it later. Right now you can see this router is DR router, right? So there is one timer for DR. It will wait for DR and BDR election for the defined timer, but if it will not receive any hello message with higher priority within that timer, then it will declare yourself as DR, right? So now you can read this output. Interface fast Ethernet 0/0. What is the process ID over here? 1. What is the area ID? 0. IP address 12.1/24. What is the cost metric? 1. Done. How it have calculated the cost? So IP OSPF. So IP OSPF. What is the reference bandwidth, guys? So interface F0/0 include. What is the reference bandwidth? 100 Mbps. What is the bandwidth of the link? 100 Mbps. So cost formula to calculate cost is reference bandwidth upon bandwidth of link, means 100 divided by 100, right? Value will be 1. So this is how this router have calculated the cost. Done. If you want to change the reference bandwidth, you can change. Configure T, router OSPF 1, auto cost reference bandwidth, let's say 200. What is saying? Reference bandwidth is changed. Now show IP OSPF. What is the reference bandwidth now? Hey guys, 200. So show IP OSPF interface brief. Cost is changed, right? 200 divided by 100. Reference bandwidth upon bandwidth of link. Got it? Now let me configure OSPF on router number 2. And before that, let me do one thing. Let me capture this link also. Done. Now R2. Config T, router OSPF, and see on this router I am going to create one loopback interface. Interface loopback 1. IP address 2.2.2.2. 255.255.255.255. Then interface F0/0. Say no set IP address 12.1.1.2. 25 25250. Then router OSPF process ID. Process ID is locally significant. What is the concept of process ID? See, on a single router we can run multiple OSPF process, right? So as we have option to enable multiple OSPF process on a single router, how you can identify both process with the help of process ID? But it is locally significant. You can configure same as well and different as well, right? So here I am going to configure router OSPF again 1, or you can configure 100, doesn't matter, right? What will be the router ID on router number 2? So IP protocol. What will be router ID, guys? 2.2.2. Highest IP address on the loopback interface. But now if I will remove the loopback interface, loopback 1, say no loopback 1. But router is not going to change their router ID. So IP protocol router ID is still 2.2.2, right? So once a router will elect router ID, after that it is not going to change it. Now I am going to advertise network here, because we do so IP OSPF interface brief. So by default OSPF is not enabled on any interface. So say router OSPF 1 and then network. Which network? 12.1.1.0 25 wildcard mask 0.0.0.255, and as I told you, area should match to form neighbor. So if I will configure area 10 here, will OSPF neighborship come up? No. See on router number 2, so IP OSPF interface brief. Yeah, OSPF is enabled on F0/0. Yes. And see the log message. It is receiving hello message from their neighbor, but the issue is mismatch area ID. Mismatched area ID. So it is giving error as well, right? Like area ID is mismatched here. How to troubleshoot this issue? See, on both routers simply you can use this command. So IP OSPF interface brief over here as well. So IP OSPF interface brief. See here area is 10 and on router number 1 area is 0. So area should be same. So on router number 2 I'm going to correct the area and see the message, hello message. If you want to see the hello messages, both routers are sending hello message. You can open any hello message. See, router is generating hello message at which layer? At layer 3, because OSPF is an layer 3 protocol, and these are the informations inside hello message. If you will open the header, see version information is there, message type is there. This is type 1 message, hello message. Length is there, then router ID is there, area ID is there, checksum field, authentication type, authentication data, right? Then subnet mask is there, hello interval is there, priority is there, date interval is there, and DR router, BDR router, right? So out of these all information, this is the hello OSPF neighborship parameter. Hello time must match. Router ID must be, this is type of message, router ID must be unique. So router 1 have 1.1.1 router ID and router 2 have 2.2.2 router ID. So both are unique. So router ID is unique. Area ID must be same. But in my scenario, area ID is not same. Here area ID is 0.0.0.0. Right? Then guys, subnet mask. This field should also match. Authentication type and authentication data must match. Hello interval must match. Priority, no. Date interval must match. Designated router and backup designated, these are not hello parameter. If you will open hello message of router 2, see router 2 hello message. 12.2 is sending this hello message. What is the area ID here? 0.0.0.10. So area ID is also represented in IPv4 format. If I will define area ID, what? 0. Area 0. So router is going to represent it like 0.0.0.0. If I am saying area 10, it will represent like 0.0.10. If I am saying area 256, then how router is going to represent this area, guys? 0.0.1.255. Getting my point? If I am saying area 257, so router is going to represent like 0.0.01 dot 1 dot or 2 dot 2.255, like this. Got it? Okay. Now I'm going to correct the area ID here. Say router OSPF 1, and let me remove the network command. Where is the network command? Here I am going to say no to this network command. Right? So both routers are not able to form neighborship. Do so IP OSPF neighbor. Reason OSPF area ID was mismatch. Now I am going to change, let's say, hello time. So here say IP command to change hello time. Okay, let me do one thing. Let me change the MTU on interface F0/0. MTU is also one parameter. So say MTU is here 100, 1000, right? MTU, and then we can say minimum 1500. So let's say 1530 byte. Now I have changed the MTU, and let me enable OSPF on F0/0. Router OSPF 1 and say network 12.1.1.0 0.0.0.255 and area 0. Will OSPF neighborship come up? No. What is the issue now? So IP OSPF interface brief. What is the issue now? See, with the help of this command, can you troubleshoot the issue now? No. Because here, see, all informations are same. All informations are same. But you can do one thing. You can debug hello message of OSPF. Debug IP OSPF hello on order number 2. Debug IP OSPF hello. See, are you able to see any MTU information here? No. There's no MTU information, right? So you need to find why neighborship is down. Why neighborship is down? You are going to run command show IP protocol to verify the OSPF configuration. Routing protocol is OSPF 1. There is no any filtering. That is fine. Router ID is also unique. Number of areas in this router is only 1. We have only one area on router number 2. Maximum path 4. That is fine. We are doing routing for 12 network. That is fine. Gateway distance. By default, distance of OSPF is 110. I'm not able to see the MTU information here, right? On router number 2, show IP protocol. No. Show IP OSPF neighbor. Yes. I'm able to see the neighbor. 2.2.2 is my neighbor. But oh my god, state is stuck in access start state. State is stuck. Means routers are not going to exchange the database. As I told you, in OSPF we have two types of neighbor. Neighbor with adjacency and neighbor without adjacency. So this is neighbor without adjacency. My neighborship is stuck in access start state. When we will discuss the OSPF neighborship state, you will learn how OSPF neighborship can stuck in access start state. And whenever OSPF neighborship is stuck in access start state, you should check MTU, right? If OSPF neighborship is stuck in access start state, guys, 90% chances MTU mismatch, right? And to verify the MTU, simply I can run command show IP interface F0/0 and let me say include MTU. MTU over here is 1500 byte, and on router number 2, show IP interface F0/0 include MTU. MTU over here is 1530 byte. So this is the issue. This is the issue. So IP OSPF interface fast Ethernet 0/0. You can use this command also to check detailed configuration of OSPF on F0/0. And so IP OSPF is also one verification command, right? So you can read this output as well. Here you have information of router ID. What is the router ID of this router, right? So this is for quality of service support. These are for quality of service. Leave it for now. You can check the hello time, hold on time, this information with the help of this command. You can check the reference bandwidth, right? You can check how many times this router have run SPF algorithm. So how many times this router have run SPF algorithm, guys? SPF algorithm executed 1 times, right? But if I will add one loopback here, interface loopback 1 and say IP address 20.1.1.0 what is happening? This is overlapping. Do so IP interface brief. We have no bad subnet mask. Oh, IP address is incorrect, sorry. 20.1.1.1. And another way to enable OSPF on an interface is simply here I can run command IP OSPF, then process ID, after that area 0. So this command will enable OSPF on interface. So we have two options to enable OSPF on interface, with the help of network command or with the help of interface. This is interface basis OSPF configuration, right? So say enter. So once you will advertise a network in OSPF, it will install that network in their database, and then again it will run what? SPF algorithm. So IP OSPF. Now you can see how many times this router have executed SPF algorithm? 2 times. So whenever change will occur, router is going to run SPF algorithm, right? And so IP OSPF interface fast Ethernet 0/0. See the detailed information. What is the network type of OSPF? Broadcast. So always keep in mind, network by default network type of OSPF on Ethernet link is broadcast. On the loopback interface, so IP OSPF interface loopback 1. On the loopback interface, what is network type by default? Loopback. So loopback is also one type of network. Done, right? So network type should be same. Now so IP OSPF neighborship is stuck because of MTU. Now I am going to change the MTU here. Interface F0/0, say MTU 1530. I am going to remove this command, say no to this. Now both routers are already exchanging hello message. So you can see these routers have formed the neighborship. So IP OSPF neighbor. Done. See, now neighborship is in full state. Full state means both router have exchanged their database. Now if you will check database of router 1, so IP OSPF database, you can see in the database of router 1 there is information of 2.2.2 also, right? So if you will open this LSA, you will get all link information which is connected with router number 2. If you will open this LSA, then you will get all network connected with router 1, right? So I can say so IP OSPF router database, then router 2.2.2. Show me the detailed information of 2.2.2. So see, there is one link where this network is running 20.1.1.0, and there is one link where this network is running. What is the cost on the link? All informations are there, right? In the same way on router number 2, show IP OSPF database. Now see guys, database of router 1, show IP OSPF database. Router 1 and router 2, database of both router is exactly same, right? Exactly same, there is no any difference, right? Means both router have information of complete topology, right? And so IP route OSPF. Now you can see router 1 is learning 20 network from the OSPF. So AD value is 110. This is the default AD value of OSPF. Other parameter of hello message is network type. What will happen if I will change network type on router number 2? Interface F0/0 say IP OSPF network. Here I am going to set point to point. So IP OSPF neighbor. Neighborship is here, right? So IP OSPF neighbor. Neighborship is there, but so IP OSPF database. Database is also so IP OSPF database. Database is also same. Clear IP OSPF process. Say yes. Let me clear the neighborship. Again, these two router will form neighborship. See, so IP OSPF neighbor, and OSPF is fast protocol. State is in two-way. Don't worry, we will discuss this state. Soon it will come in full state. What happened? Here neighborship is in access start. Here neighborship is in two-way. How you will troubleshoot it? Now tell me, how you are going to troubleshoot it? On router number 1, neighborship is stuck in two-way state. On router number 2, neighborship is stuck in, now neighborship is in full state on router number 2. On router it's showing full state. On router 1 it's showing now full state. So OSPF is slower protocol in this scenario. To make it faster, you have to change the network type. On both router you should configure network type what? Point to point. As I told you, between two routers, if two routers are directly connected with each other, the network type should be point to point. So in this scenario, both routers have neighborship and so IP OSPF database. Database as well. So IP OSPF database. Database is also similar. So IP route OSPF. But router 1 does not have any route in the routing table from router number 2. Router 2 is advertising 20 network. So IP OSPF database, you can see in the database, right? There is LSA of router number 2. This is router ID of router 1 now because it have elected this router ID automatically. The reason, there is no loopback. I have not configured manually, so it have picked the physical interface IP address. If you want to configure it here, router ID, simply you can say router OSPF 1, router ID 1.1.1.1, but I can't. Reason, router 1 have already shared their database to router number 2. So say do clear IP OSPF process. So I have break the neighborship and then I am going to say router ID 1.1.1. Now it will set router ID 1.1.1. So IP OSPF database. Just wait. Soon it will form neighborship. So IP OSPF neighbor. How you are going to troubleshoot this scenario? If route is available in the database but router is not installing in routing table, that means there is some issue with network type. There is some issue with network type. But what I told you guys, network type is parameter of neighborship. Means if network type is not same, then router should not form neighborship, right? But few network types are compatible with each other, right? But they cannot communicate. On router number 2, I have one loopback 20.1.1.1/24, and on router number 1 also I am going to create one loopback 10.1.1.1/24, and on router number 1 I am going to advertise this network in OSPF interface loopback 1 IP address 10.1.1.1 255.255.255.0 and say IP OSPF 1 area IP OSPF 1 area 0. Now so IP OSPF interface brief, you can see OSPF is enabled on both interface, and so IP OSPF neighbor, we have neighborship, so IP OSPF database, right? Both router are there in the database. Now database looks different, right? Because guys, earlier we had two number of LSAs, two different LSAs, LSA1 and LSA2, but now we have only one LSA. Don't worry about the LSAs, because in next class we are going to talk about LSAs only, right? On router number 2, say the database, check the database, so IP OSPF database looks same, but so IP route OSPF, so IP route OSPF. Why router 1 is not installing 20 network in their routing table? So IP OSPF database and then router and 2.2.2 show me the detailed information of this LSA, and see inside this LSA 20 network is there, right? 20 network is there, but router is not installing it in their routing table. So to troubleshoot it, what you can do, check the neighborship in detail. So IP OSPF interface F0/0 and include, what we can say, include network, yes, and on router number 2 also, so IP OSPF interface F0/0 include network. Network type over here is point to point, and network type on router number 1 is broadcast, right? Here network type is broadcast, here network type is P2P, right? So this is the reason. On router number 2 also you can check the routing table, so IP route OSPF, it have not installed any route, but so IP OSPF database router 2 have information about 1.1.1, and even you can open it in detail, so IP OSPF database router and 1.1.1.1. see there is 10 network information, but router 2 is not installing it in their routing table because of network type. We will have one separate class on OSPF network type, guys, because it is very important, so don't worry. For now I am going to change network type. On router number 1 also I am going to say interface F0/0 and then IP OSPF 1 IP OSPF network point to point. So as you have configured network type point to point, now OSPF neighborship will come up quickly, right? Now OSPF will work fast. So what we can do to verify it, simply say clear IP OSPF process and say yes. Now it will break the neighborship, and so IP OSPF neighbor, you can see neighbor is in full state, right? Earlier it was taking time. So that's why network type is most important, and it depends on the scenario. By default network type on fast Ethernet link is broadcast, but if you are connecting two routers together, then network type should be point to point. We'll see the reason, everything step by step. Don't worry, we will have one separate session on network type. So this is also one neighborship parameter. By default OSPF network type depends on link, like on fast Ethernet link by default, or on any Ethernet link, OSPF network type is by default broadcast. On serial link, by default OSPF network type is point to point. On loopback interface, by default OSPF network type is loopback. So if between router 1 and router 2, if I will connect one serial link, let's say 3/0 and on the 3/0 also I'm going to configure one IP, let's say on router 1 interface as 3/0, say no such, sorry, interface as 3/0, say no such, and IP address 21.1.1.1.255.255.255.0, say IP OSPF 1 area 0. Right now, so IP OSPF interface brief, you can see OSPF is enabled on all the interfaces. Go to router number 2. On router number 2, interface serial 3/0, say no such, and IP address 21.1.1.2.255.255.255.0 and IP OSPF 1 area 0. Now on the serial link, see the by default network type. So IP OSPF interface F0/0 include network. Network type is by default point to point. Cost is 1. But guys, by default reference bandwidth is 100, but sometime you need to change the reference bandwidth. Let me finish this. After that, we'll finish today's session. We'll continue tomorrow. So IP OSPF. Here by default reference bandwidth is 100 Mbps, correct? By default, OSPF uses a reference bandwidth 100. Now just try to understand one scenario here. R1 connected with two different router or two different, let's say, ISP, right? The bandwidth of this link is 200 Mbps. Bandwidth of this link is 500 Mbps, right? This is R1, R1, R2, R3, right? Here network is 12.1.1.0/24 and here network is 13.1.1.0/24. Done. Now guys, I have enabled OSPF on all routers. I have advertised all interfaces in, let's say, area 0. So tell me, according to you, which path is the best path? Upper path or lower path? Let's say both routers are advertising one network, that is 1.1.0/24. Router 2 is also advertising this network and router 3 is also advertising this network 1.1.1.0/24. So on router number 1, which path is the best path according to you? Upper path or lower path? Lower path, because here we have more bandwidth, 500 Mbps, correct? Now to identify best path, router 1 is going to find what? Metric, means cost. Cost on the upper link, reference bandwidth, which is 100 upon bandwidth of link 200. What value it will get? 0.5. So whenever router will calculate cost less than 1, it will consider it as 1, right? So cost on the upper link is 1. In the same way, it will calculate cost on lower link. So again, formula is 100 Mbps upon bandwidth of my link 500. What value it will get? 0 point something. So it will consider what? 1. Now see, according to OSPF, cost on both paths is same, 1, 1. Router will start performing what? Load balancing, right? Equal cost load balancing. So whenever you have link whose bandwidth is more than 100 Mbps, in that scenario you should change what? Reference bandwidth, right? Reference bandwidth is 100 by default, and this is good for the link whose bandwidth is up to 100 Mbps, right? Because let's say here bandwidth is 100 Mbps, here bandwidth is only 10 Mbps. So this time router can identify which path is the best path, because here it will calculate cost. Cost will be 100 divided by 100, value 1. Here it will calculate cost. Cost is equal to 100 by 10. Here it will get what cost? 10, right? So lower value is more preferable. It will install upper path. But if link bandwidth is more than 100 Mbps, then it will calculate, OSPF will calculate same cost, right? So for Gbps link, guys, it is going to calculate same bandwidth if reference bandwidth is 100. So that's why you should change the reference bandwidth in that scenario. So interviewer can ask you, tell me the scenario where I need to change reference bandwidth, right? So in this scenario, see, I have just changed the network type, so IP OSPF database, done, and so IP route OSPF. Router 1 is learning 20 network. Is learning 20 network from which router? From this neighbor, right? And why it is not performing load balancing? So IP OSPF interface brief. Reason for not performing load balancing: on serial link cost is 129. On fast Ethernet link cost is 2, right? So if I am going to configure, let's say on serial link, I am going to configure bandwidth. On serial link, bandwidth is, it is 100 Mbps, 100 Mbps, and on fast Ethernet link, I am going to configure bandwidth 1, 2, 3, 4, 5, 6, 2, 4, 5, 2, 4, 5, 6. What will happen in this scenario? Can router 1 identify which path is the best path? Interface range F0/0 and say serial 3/0. Not use range command because I need to configure different bandwidth, sorry. F0/0, say bandwidth is, what happened, how to configure bandwidth 1, 2, 3, 4, 5, 6, and on serial interface serial 3/0, bandwidth is 1, 2, 3, 4, 5. So IP OSPF interface brief, cost is 2 on the serial link, cost is 1 on the fast Ethernet link. Okay, let me do one thing. On fast Ethernet link, in this scenario it is able to find the best path. But now what I am going to do, on serial 3/0, bandwidth is 1, 2, 3, 4, 5, 6, 7, and on fast Ethernet 0/0 interface F0/0, bandwidth is, actually by default reference band, here reference bandwidth is not by default bandwidth on router number 2, router number 1. That's why it is calculating different cost. So but here I am going to set 1, 2, 3, 4, 5, 6, 7, 8. Okay, leave it. Here on the serial link also I am going to set the reference bandwidth, sorry yaar, serial 3/0, and let me remove this bandwidth command. And bandwidth on the serial link was what, 150, 5 times 0 means 100 Mbps, 245. Now so IP OSPF interface brief, see, on the serial link cost is 2, on the fast Ethernet link cost is 1. That is correct, OSPF is working fine. So IP OSPF, because reference bandwidth is by default 200. Now I am going to set reference bandwidth 100 here. A router OSPF 1 and say auto cost reference bandwidth default is 100, right? See, reference bandwidth is changed. So IP OSPF, now reference bandwidth is default 100, correct? And so IP OSPF interface brief. Cost is same on both link, correct? But bandwidth is not same, right? So interface serial 3/0 include bandwidth, and so interface F0/0 F0/0 bandwidth. See, bandwidth is different. Then also OSPF is calculating what, guys? Same cost. So whenever you have link whose bandwidth is more than 100 Mbps, in that scenario you have to change reference bandwidth. So here if I will set reference bandwidth 200, automatically OSPF will calculate different metric on different link. Right now it is calculating 1. So whenever OSPF is going to calculate cost value less than 1, then it will consider it as 1, right? So say router OSPF 1, and this scenario it will perform load balancing. So IP route OSPF. Now you can see router 1 is performing load balancing. It have installed both path in their routing table, right? It is performing which type of load balancing? Per packet or per destination? Interface F0/0 IP load sharing. See, we have two types of load balancing, per destination and per packet. By default is per packet, but if you want to configure per destination you can, right? Let's suppose for a particular application I want to forward traffic from a separate link, from a separate path, right? So I can change the load balancing algorithm. But now here I am going to change reference bandwidth. Router OSPF 1 auto reference bandwidth 500. Reference bandwidth is changed, so IP OSPF now reference bandwidth is, you can see, 500, right? And as now reference bandwidth is 500, right, greater than the link of my physical interface, it will calculate accurate cost, accurate metric, right? So IP OSPF interface brief. Now you can see cost on serial link is 5 and cost on fast Ethernet link is 1, right? So this was basic things about OSPF. Today we have covered many basic things. Let me revise you. First of all, the syllabus of OSPF, then the scenario where we are going to use OSPF in real-time network, and after that some basic concepts, right? We have also seen the difference between distance vector and link state. Okay, so these are, guys, basic points about OSPF routing protocol, like what to multicast addresses OSPF is using, default reference bandwidth, cost, what is the cost means metric, it is layer 3 protocol, and classless routing protocol. Protocol number is 89. It is an IGP protocol, open standard, it uses SPF algorithm, these things. Then types of messages. After that we have seen one message, first message of OSPF, that is hello message. Then contents of hello message and neighborship parameter. After that we have seen basic configuration and router ID as well, right? Now tomorrow I will start from this message DBD, and before talking about DBD you have to understand states, neighborship states. Okay, so if I will talk about the OSPF neighborship state, let me write down here topic for tomorrow. Tomorrow we are going to cover a state. So first state is down state. Down state means we have enabled the OSPF, router is sending hello message from that interface, but it is not receiving any hello message on that interface. So that interface will consider as down in OSPF. Then we have attempt state in case of, again, static neighborship only, right? This is optional. In case of static neighborship you will have attempt state. In dynamic you will have directly down, after that two-way. And if MTU will mismatch, then OSPF neighborship will stuck in down state only. Then guys, X start state, then we have exchange state, then loading state, and after that full state. So now you can see we have full state. So IP OSPF neighbor full state, that means this neighbor is adjacent, right? If neighborship state is in two-way, that means neighbor order are my neighbor in OSPF but not adjacent, means I will not share the complete database, that is only neighbor. जैसे एक होता है ना, एक कैसे नेबर होते हैं जिसके साथ अपन खाना वाना भी शेयर करते हैं, अरे यार मेरे घर में कुछ स्पेशल बना है, चलो मैं अपने नेबर को देते हैं। और एक टाइप का नेबर कैसा होता है कि नेबर तो है लेकिन हम कभी उससे बात भी नहीं करते हैं, है ना। तो ओएसपीएफ में टू वे स्टेट वाला नेबर वैसा ही है, भाई तुम मेरे नेबर तो हो लेकिन हम तुमको कोई इन्फॉर्मेशन नहीं देने वाले हैं और ना तो तुमसे लेने वाले हैं। और नेबर विथ एडजेसेंस मतलब जो फुल स्टेट में है वो कैसा क्लोज नेबर जो होते हैं जिसके साथ हम खाना शेयर करते हैं, राइट, सारे कुछ शेयर करते हैं। क्लियर गाइस? सो एक्चुअली डाउन स्टेट मींस OSPF is not receiving any hello message on the interface R1 R2, right? Once you will advertise this interface in OSPF, router 1 will start sending hello message, right? But if it is not receiving, that means this interface is down. Then you will enable OSPF on router 2 also. So router 2 is also going to send their hello message. Now routers are going to check parameters. When router 1 will receive hello message of router 2, it will check parameters. If parameters will match, then state will move, right? So after receiving the hello message from router number 2, once router 1 will receive hello message on this interface, state will directly move from down to two-way. And guys, remember, check the content of hello message. Content of hello message, there is one important information, that is neighbor router ID, right? Neighbor router ID. So actually what will happen when these two routers will come up, right? When router 1 will receive first hello message of router 2, router 2 is sending their first hello message to router number 1. So in that hello message, it will not include neighbor router ID because router 2 don't know who is the neighbor. Router 2 is discovering the neighbor. But after receiving the hello message from router number 1, in the next hello message of router 2, it will include their neighbor router ID, right? Router ID of R1 1.1.1.1 2.2.2.2. So in the second hello message, router 2 is going to send their on router ID as well as router ID of neighbor 2.2.2.2. And once router will receive a hello message with their on router ID, state will directly move from two-way to X start. First, when it will receive hello message, state will move to two-way. In two-way, it will check, is neighbor router sending my neighbor ID in the neighbor router ID field? If yes, then state will move to X start. So two-way state is generally used to check bidirectional connectivity. Now if we have capturing, if you will open this capturing any hello message, see, let me open the any hello message. Who is sending this hello message? 12.1, right? Destination multicast address. And is their neighbor IP address? Yes, active neighbor is 2.2.2. So router 1 is sending neighbor ID of their neighbor, right? So once router will see their on router ID in the hello message, state will move from two-way to X start. In X start state, routers are going to exchange type 2 message. Type 2 message means DBD message, right? After exchanging DBD message, neighborship state will move to exchange state. In exchange state, both routers are going to exchange their LSA's header. LSA's header means just like menu card of a restaurant. So in the restaurant, let's say you want to order burger, right? So once you will enter in the restaurant, first receptioner will give you the menu card. Menu card carry what, guys? Just a header of all available foods. Like we have burger, we have pizza, we have X, Y, Z, blah blah blah. In the same way, with the help of LSA header, router 1 is going to share header of their database. Means I have 10 network, I have 20 network, I have 30 network. Not complete information of 10, 20, 30 network, right? Just a header in the exchange state. Then when router 2 will receive the header message from router number 1, it will see, okay, router 1 have 10 network, 20 network, 30 network. And suppose router 2 already have 10 network. So router need 20 and 30 network from router number 1. So it is going to send what? LSR. In which state? In the loading state. LSR. LSR, link state request, means router 2 will request for these two network information. Then in the same loading state, router is going to send LSU. LSU, update message. And then router 2 will send what? Acknowledgement. And after exchanging the acknowledgement, neighborship will come in full state. So full state means all database has exchanged. Full state means OSPF database has exchanged. Done? Clear? Any question? Any question to anyone? Please ask. Now I am available for next 10 minutes to resolve your query if you have any. Otherwise today we have cover basic things only. Tomorrow we will see the advanced configuration. Not advanced, first let me discuss basic things only for next 2 to 3 class, then we'll see the advanced configuration. Yeah guys, go ahead if anyone have question. Oh my god, it's 10:40. Hey, it's not fair.